left to their own devices, large language models have a bit of a knowledge problem. If a piece of information wasn't in their training set, they won't be able to recall it. Maybe something newsworthy that happened after the model completed training, such as who won the 2025 Best Picture at the Oscars, or it could be something proprietary like a client's purchase history. So to overcome that knowledge problem, we can use augmented generation techniques, like, for example, retrieval. So retrieval, augmented generation, otherwise known as RAG. Now, how does that work? Well, essentially, we have here a model, and the model is going to query an external searchable knowledge base. Here's where we've got our knowledge. And that's going to return portions of relevant documents to provide additional context. So we get the documents, we get some context, and we pass that to the LLM model to update its knowledge, if you like. And that updated context, that's used to generate an answer. Anora, that won Best Picture this year, probably got it out of that data set. But retrieval isn't the only augmented generation game in town. Another one is cache augmented generation, or CAG. Now, CAG is an alternative method. So rather than querying a knowledge database for answers, the core idea of CAG is to preload the entire knowledge base. So we take everything we know and we put it all into the context window. All of it. The Oscar winners, last week's lunch special at the office cafeteria, whatever you want. So rather than feeding the model just curated knowledge, we are feeding the model everything, not just the stuff we deemed relevant to the query. So RAG versus CAG. Let's get into how these two things work, the capabilities of each approach, and an enticing game to test your own knowledge. And let's start with RAG. So RAG is essentially a two-phase system. You've got an offline phase where you ingest and index your knowledge, and then you've got an online phase where you retrieve and generate on demand. And the offline part, pretty straightforward. So you can start with some documents. So this is your knowledge. This could be Word files, PDFs, whatever. And you're going to break them into chunks and create vector embeddings for each chunk using the help of something called an embedding model. Now that embedding model is going to create embeddings and it's going to store them in a database. And specifically, this is a vector database where the embeddings are stored. So you've essentially now created a searchable index of your knowledge. So when a user prompt comes in from the user, this is where the online phase of this is going to kick in. So first thing that's going to happen is we're going to go to a RAG retriever, and that RAG retriever is going to take the user's question and it's going to turn it into a vector using the same embedding model that we used earlier. And that's going to perform a similarity search of your vector database. Now that's going to return the top K most relevant document chunks from here that are related to this query. There might be something like 3 to 5 passages that are most likely to contain the answer to the user's query. And we're going to take those chunks and we're going to put them into the context window of the LLM alongside the user's initial query. And all of this is then going to get sent to the large language model. So the model is going to see the question the user submitted plus these relevant bits of context and use that to generate an answer. We're basically saying to the model, here's the question, here's some potentially useful information to help you answer it that we got out of this vector database, off you go. And the beauty of RAG is that it's very modular. So you can swap out the vector database, you could swap out a different embedding model, or you could change the LLM without rebuilding this entire system. That's RAG. What about CAG? Well, CAG takes a completely different approach. So instead of retrieving knowledge on demand, you front load it all into the model's context all at once. So we'll start again with our documents. This is all of our gathered knowledge, and we're going to format them into one massive prompt that fits inside of the model's context window. So here it's going to fit into this. Now this could be tens or even hundreds of thousands of tokens. And then the large language model is going to take this massive amount of input and it's going to process it. So effectively this kind of knowledge blob is going to be processed in a single forward pass, and it's going to capture and store the model's internal state after it's digested all of this information. Now this internal state blob, it's actually got a name. It's called the KV cache, or the key value cache, and it's created from each self-attention layer, and it represents the model's encoded form of all of your documents, all of your knowledge. So it's kind of like the model's already read your documents and now it's memorized it. So when a user submits a query in this situation, then we take all of this KV cache and we add the query to it, and all of that gets sent into the large language model. And because the transformers cache has already got all of the knowledge tokens in it, the model can use any relevant information as it generates an answer without having to reprocess all of this text again. So the fundamental distinction between RAG and CAG comes down to when and how knowledge is processed. With RAG, we say, let's fetch only the stuff that we think we're going to actually need. CAG, that says, let's load everything, all of our documents up front and then remember it for later. So with RAG, your knowledge base can be really, really large. This could be millions of documents stored in here because you're only retrieving small pieces at a time. The model only sees what's relevant for a particular query. Whereas with CAG, you are constrained by the size of the model's context window. Now, a typical model today that can have a context window of something like 32,000 to 100,000 tokens. Some are a bit larger than that, but that's pretty standard. It's substantial, but it's still finite, and everything, all of these docs need to fit in that window. So let's talk about capabilities of each approach, and we're going to start with accuracy. Now, RAG's accuracy is really intrinsically tied to a particular component. When we talk about accuracy with RAG, we are talking about the retriever. That's what's important here, because if the retriever fails to fetch a relevant document, well, then the LLM might not have the facts to answer correctly. But if the retriever works well, then it actually shields the LLM from receiving irrelevant information. Now, CAG, on the other hand, that preloads all potential relevant information, so it guarantees that the information is in there somewhere, I mean, assuming that the knowledge cache actually does contain the question being asked. But with CAG, all of the work is handed over to the model to extract the right piece of information from that large context. So there's the potential here that the LLM might get confused, or it might mix in some unrelated information into its answer. So that's accuracy. What about latency? Well, RAG, that introduces an extra step, namely the retrieval into the query workflow, and that adds to response time. So when we look at latency with RAG, it's a bit higher because each query incurs the overhead of embedding the query, of then searching the index, and then having the LLM process the retrieved text. But with CAG, once the knowledge is cached, answering a query is just one forward pass of the LLM on the user prompt plus the generation. There's no retrieval lookup time. So when it comes to latency, CAG is going to be lower. All right, what about scalability? Well, RAG can scale to as much as you can fit into your vector database. So we can have some very large data sets when we are using RAG. And that's because it only pulls a tiny slice of the data per query. So if you have 10 million documents, you can index them all and you can still retrieve just a few relevant ones for any single question. The LLM is never going to see all 10 million documents at once, but CAG, however, that does have a hard limit. So with CAG, the scalability restriction is basically related to the model context size. We can only put in there what the model will allow us to fit. And as I mentioned earlier, that's typically like 32 to 100K tokens. So that might be a few hundred documents at most. And even as context windows grow, as they are expected to, RAG will likely always maintain a bit of an edge when it comes to scalability. One more, data freshness. Now, when knowledge changes, RAG, that can just, well, it can just update the index very easily. So it doesn't take a lot of work to do that. It can update incrementally as you add new document embeddings or as you remove outdated ones on the fly. It can always use new information with minimal downtime. But CAG, on the other hand, that is going to require some recomputation when anything actually changes. If the data changes frequently, then CAG kind of loses some of its appeal because you're essentially reloading often, which is going to negate the caching benefit. All right, so let's play a game. It's called RAG or CAG. Now I'm going to give you a use case and you're going to shout out RAG if you think retrieval augmented generation is the best option, or you'll yell out CAG if you think cache augmented generation is the way to go. Ready? All right. Scenario one, I am building an IT help desk bot. So users can submit questions and the system's going to use a product manual to help augment its answers. Now, the product manual is about 200 pages. It's only updated a few times a year. So RAG or CAG? Don't be shy. Getting acronyms at the screen is an entirely normal process. All right, I'm going to imagine that most people here are probably saying CAG for this one. The knowledge base, in this case, the product manual, it's small enough to fit in most LLM context windows. The information is pretty static, so the cache doesn't need to be updated very frequently. And by caching the information, we'll be able to answer queries faster than if we had to query a vector database. So I think CAG is probably the answer for this one. What about scenario two? So with this one, you're going to be building a research assistant for a law firm. Now the system needs to search through thousands of legal cases that are constantly being updated with new rulings and new amendments. And when lawyers submit queries, they need answers with accurate citations to relevant legal documents. So for this one, RAG or CAG? I think RAG is the way to go here. The knowledge base in this case, it's massive and it's dynamic with this new content being added all the time. So attempting to cache all this information would quickly exceed most models' context windows, and also that requirement for precise citations to source materials is actually something that RAG naturally supports through its retrieval mechanism. It will tell us where it got its information from. And also the ability to incrementally update the vector database as new legal documents emerge means that the system always has access to the most current information without requiring full cache recomputation. So RAG all the way here. One last game of RAG or CAG. So scenario three, you're building a clinical decision support system for hospitals. And the idea here is that doctors need to query patient records and treatment guides and drug interactions. And the responses need to be really comprehensive and of course very accurate, because they're going to be used by doctors during patient consultations. And the doctors are often going to ask complex follow-up questions. So RAG or CAG for that? Well, how about both? Because in this case, the system could first use RAG to retrieve the most relevant subset from the massive knowledge base. So pulling in specific sections of a particular patient's history and some research papers that are based on the doctor's query. And then instead of simply passing those retrieved chunks to the LLM, it could load all that retrieved content into a long context model that uses CAG, creating a temporary working memory, if you like, for the specific patient case So it's really a hybrid approach. RAG's ability to efficiently search enormous knowledge bases, and then CAG's capability for providing the full breadth of medical knowledge when needed for those follow-up questions without the system repeatedly querying the database. So essentially, RAG and CAG are two strategies for enhancing LLMs with external knowledge, and you'd consider RAG when your knowledge source is very large, or it's frequently updated, or you need citations, or where resources for running long context window models are a bit limited. But you would consider CAG when you have a fixed set of knowledge that can fit within the context window of the model you're using, where latency is important, it needs to be fast, and where you want to simplify deployment. RAG or CAG, the choice is up to you.